Flip to the next page, and we're going to talk about something called the third angle conjecture. Now, some of these properties, of course, if you just think about them for a second, they make some logic sense here. If we were doing this in class, we might do a little investigation as it talks about in the first paragraph. It says, draw a triangle on a piece of paper, create a second triangle on a piece of patty paper by drawing a segment that is longer than the bottom of the first triangle. Then trace the bottom two angles from your first triangle onto either side of the new triangle. Extend the angle segments until they cross. Compare the top angle in each triangle. What is true? In other words, if we create a triangle, whatever triangle you want, let's just say like this one over here, which is an acute triangle. Actually, it might be just slightly obtuse, isn't it? It's for sure scalene. But in any case, if we then create a second triangle that has a different length bottom segment, a different base segment length on the bottom, but has the same measures for the two angles. So these angles right here would be the same as these angles here. What is going to be true about the third angle? Clearly, these triangles themselves are not congruent to each other. They don't have the same length sides, but they do have some congruent angles here and here, and then on the bottom pair over here. What is true about that third angle? And what is true about that third angle, of course, is that those third angles must also be congruent. Okay, so please write down the property here. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. All right, so if those first two angles added up to 100 degrees, for instance, then that third angle would have to be 80 degrees in both those triangles. If the first two angles in one triangle added up to 130 degrees, then the remaining angle in each triangle must be 50 degrees. So angle 1 has to be congruent to angle 2 if the other pairs of angles are congruent. That's called the third angle conjecture, third angle property. All right, so let's apply some of this to the diagram down below here. So we know some things in this diagram. We know we have a 60-degree angle and a 40-degree angle and a 60-degree angle over here. And the question is ACB, all right, so let's see here, is ACB, so that's this angle right here. Let's see, different color. Is this angle right here, is that congruent to EDB? So that would be this angle right here. So based on the information. So if I were looking at this, thinking about the property that we just have, I kind of notice that we've got 40 degrees here. Well, I also know this one's 40 degrees, right? Because these are vertical angles with each other. And now, let's just think about it. I have two angles in this triangle are congruent to two angles in this triangle, so then their third angles must be congruent because of the third angle conjecture. And if I wanted to think about that just a little bit more clearly here, I might say, well, by the triangle sum conjecture, I know this is 80 degrees because they all have to add up to 180, and this is also 80 degrees. So not only are they congruent, but I know exactly what those angle measures are. So if I'm going to explain that, kind of like in a little mini proof here, I might say something like, oops, let's try that again. I might say something like ABC and DBE are both 40 degrees by the vertical angle conjecture, so we're just explaining our reasoning here. And since 60 and 40 add up to 100 degrees, then we know by the triangle sum conjecture that the remaining angles are both 80 degrees. So that's one way of proving it. So actually I just mentioned the triangle sum conjecture in that proof. The other way you could do it is say these are both 40 degrees by the vertical angle conjecture. And since 40 and 60 degrees are the same in both of the triangles have a 40-degree angle, a 60-degree angle, then by the third angle conjecture, the remaining angles, which would be ACB and EDB, are both congruent to each other. Regardless of their measures, they are congruent. All right, so basically just explaining your reasoning, and you're going to have to continue to do that. in geometry here, we're going to be thinking about the logic. So it's kind of like showing your work in algebra. You've got to explain yourself a little bit using some sentences and using your words. All right, that's it for chapter 4.1 or section 4.1 on triangle sum conjecture. We're also going to cover properties of special triangles. So once again, sketch this out in your notes. So we have an isosceles triangle here, and I have it in my notes here, but you do not have it on your page, so I'd like you to sketch this in right here. And if we were doing this out of the book, we go through these directions. So we construct an isosceles triangle. So you use your compass, construct an isosceles triangle. But if you just want to sketch that in, I guess that's fine for now. If you can quickly construct it, that's fine also. And then label the different parts, please. So label the different parts, and I'm going to get rid of this for the moment here. Label the parts. I need you to be able to know when I say the legs of the isosceles triangle, you need to know that those are the two congruent sides of the isosceles triangle. When I say the vertex angle or the vertex, that's referring to where the two congruent sides meet. That's the vertex angle of an isosceles triangle. So I need you to make sure you label the vertex angle. Of course, by definition, an isosceles triangle has a pair of congruent sides, which are the legs. And then the other angles are called the base angles, because the base would be, sometimes we refer to the base as the bottom of the triangle, but really it's where the non-congruent sides meet. The congruent sides meet at the vertex angle, the non-congruent sides meet at the base angle. All right. So if we then take out and measure our base angles, if we have an isosceles triangle, not only do we have two congruent sides in a triangle, we also have a pair of congruent angles. All right. So that is one of the properties of isosceles triangles. By definition, it's simply a triangle with one pair of congruent sides. But another property of isosceles triangles is stated as the isosceles triangle conjecture. And that says if a triangle is isosceles, then the base angles are congruent. So in other words, if I have this, if I have an isosceles triangle, by definition, it would simply be a triangle with two congruent sides, then I also have two congruent angles. So the base angles are congruent. So make sure that you've got the congruent angles would be the angles between the non-congruent sides. So here and here. So don't mistakenly put a congruent angle up at the vertex. It's these two angles that would be congruent to each other. So that, once again, that is a characteristic of isosceles triangles. It is not part of the definition, but we can now move forward and know that base angles in every isosceles triangle are congruent.